Okay, today's objective is I can justify shapes using slope and distance. And we're going to deal with 4 specific shapes today, and we might include a rhombus in these, but we're going to deal with parallelogram, rectangle, square, trapezoid, and like I said, we might include a rhombus later on. You'll probably have to pause the video at this point in order to get this table down, and then I'll scroll to the next page. Okay, we're only going to do a couple examples today. Example 1, we're going to graph 4 points to make a quadrilateral, and then we're going to justify the shape. Okay, here are the 4 points. A is -2, 3, B is 4, 6, C is 4, 2, and D is -2, -1. And we're going to go ahead and plot those on an XY axis. So go ahead and make an XY axis. And now let's plot the 4 points together. I'm going to plot A first. So I'm going to go -2, up 3. This is A. -2, 3. And then I'm going to do B. B is to the right 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6. B is 4, 6. Then I'm going to do C, which is to the right 4, up 2. C, 4, 2. And D is -2, -1. Left 2, down 1. D. -2, -1. And then I'm going to connect the dots. Okay, so after I connected the dots, obviously to me it looks like a parallelogram, but we need to justify this. So, referring back to our table, the way we justify that a quadrilateral is a parallelogram is we show it has 2 sets of parallel sides. So I'm going to go ahead and write that down. Okay, so I'm going to justify ABCD as a parallelogram by showing it has 2 sets of parallel sides. I'm going to go ahead and flip to a blank screen, but I am going to take the graph with me. Okay, we're going to start by looking at the 2 vertical slopes. So line segment AD, so I'm looking from here to here, and line segment BC from here to here. AD, BC. And I see they're both vertical, so I don't really need to use the distance formula for this specific problem, or excuse me, the slope formula, because I know the slopes of vertical lines are always undefined. So both of these, I'm going to write AD slope is undefined and BC slope is undefined. Okay, now we're going to look at the slope of segment AB. So I'm going to say, what's the slope of segment AB? And I'm going to also look at the slope of segment DC. DC. You'll see I included segments over those top 2. I forgot there. So we're talking about this segment from here to here, and this segment from there to there. And slope, I don't really need a formula. I'm just going to basically, I can do rise over run. So this one, I'm going to rise 1, 2, 3, and I'm going to run 1, 2, 3, 4, 5, 6. So my slope here is 3 over 6, which reduces to 1/2. And then I'm going to look over here and I'm going to see if this follows that same 3, 6, or 1/2 pattern. And so I'm going to go up 1, 2, 3 right there, or 1, 2, 3, 4, 5, 6. And it does follow that same stair-step pattern. So I know DC is also 1/2. So I'm going to highlight these. Okay, therefore, we have a symbol for the term therefore. So I'm going to write it this time. Whoops. Let me change my pen. Therefore, we just do 3 dots like this. Dot, 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 dot. I could say segment AD is parallel to segment BC. And segment AB is parallel to segment DC. And our final conclusion, again, I'm going to use the 3 dot system here. Therefore, the quadrilateral ABCD is a parallelogram. Because it has 2 sets of parallel sides. Because it has 2 sets of, and I'm going to use the parallel symbol again, sides. Okay, flipping to a new screen, example 2. Okay, example 2, graph and justify. So go ahead, we're going to plot the 4 points. A is 0, 4, B is 4, 2, C is 2, negative 2, and D is negative 2, 0. We're going to put those on an XY axis, and then we will see what it looks like and justify what we think it is. Okay, so I'm going to go ahead and make my XY axis. Okay, let's go ahead and plot the 4 points. And get in the habit of labeling them correctly, please. So this point up here is A, and that's at 0, 4. Over here at B is the coordinate point 4, 2. C down here at the bottom is the coordinate point 2, negative 2. And D is the coordinate point negative 2, 0. And then I'm going to go ahead and connect the dots, and it looks like a square to me, but we have to justify it. Okay, our job now is to justify that quadrilateral ABCD is a square, and we're going to do that in 2 ways. Number 1, we have to determine, so go ahead and put a 1 here, that we have 4 right angles. 4 right angles. So I'm going to come over here to my diagram, and I'm going to start figuring out rise over run. So let's start off by finding the slope of segment AD. So segment AD, slope equals, and I come over here to my diagram, and I notice that the slope from D rises 1, 2, 3, 4 and runs 2. So rise 4, run 2, which is simplifies down to 2 over 1. Okay, likewise, let's find the slope of DC. Okay, and the slope from D to C, I can see goes negative 2 down 2 over 4. So we're talking about this segment from here to here. And the slope of that is negative 2 over 4, which reduces to negative 1/2. Therefore, segment AD is perpendicular with segment DC. So AD is perpendicular, remember the upside down T, with segment DC, which makes the measure of angle CDA equal to 90 degrees. And I can come over here to my drawing and indicate that this is a 90-degree angle. And again, I know this because the slopes are opposite inverses. So I take the fraction, I flipped it, change the sign. Okay, next one. Let's look at segment AD and AB. So we already know the slope of AD. The slope of AD is in orange over here. It's rise 4, run 2, which reduces to 2 over 1. So we can just indicate that. Okay, so when I look at the slope of AB now, because I want to compare segment AD with AB, and we want to see if their slopes are also opposite reciprocals. Okay, so I'm going to see that A goes down 2 and goes over 4. So segment AB, right there, also has a slope of negative 2 over 4, which reduces to negative 1/2. And you'll see that those two slopes are opposite reciprocals. Flip the fraction, change the sign. Therefore, segment AD is perpendicular with segment AB, making the measure of angle DAB equal to 90 degrees. And we can indicate that over here in our drawing, DAB. Okay, and we just have to go through this process one more time. We need to look at angle ABC, and if I have 3 angles that add up to 90, the fourth one has to add up to 90. So I'm going to go through this process one more time. Okay, I already know the slope of AB is negative 1/2. What I want to know now is what is the slope of BC here. So I'm looking at this line right here. So again, I rise 1, 2, 3, 4. I run 2. So 4 over 2, which reduces 2 over 1. And these are also opposite inverses, and reciprocals we call it. So therefore, segment AB is perpendicular with segment BC, which makes the measure of angle ABC equal to 90 degrees. And I can mark that on my graph. Okay, so if we have 3 right angles, then the fourth one has to be a right angle. So our final conclusion here, therefore, there are 4 right angles. 4 right angles, and I'll go ahead and mark that. Okay, now we just have to determine the lengths. I know there's a lot of work that goes into these justifications, but you have to show mathematically, that you're proving that these are 90-degree angles. You can't just eyeball it and say, it looks like a 90-degree angle to me. Okay, I need to see your rationale, your thought process. Okay, so I'm going to take this same, we're going to use the distance formula to prove our lengths here. So I'm going to flip to a new screen, and then we're going to write out the distance formula, and then we're going to start plugging these points in. Okay, so we have these 4 points, and mathematically I want to prove that they are all congruent or equal in length. So I'm going to basically do the distance formula 4 times and make sure I have it right. Okay, so I'm looking for the distance of AB, and you'll notice I put the distance formula there. So AB is equivalent to, and I'm going to put a big long square root sign. I'm going to go ahead and put in the parentheses, and I know I got to square that. I know I'm using subtraction here. And then I'm just real careful when I'm plugging my numbers in. So my x2, so I might as well come up here and indicate what's x2 and x1 for points A and B. And I see that x2 has a 4 above it. x1 has a 0 above it. y2 has a 2 above it. y1 has a 4 above it. And that turns into 4 squared plus negative 2 squared, which is 16, plus 4, which is 20. The square root of 20, which, when you type in your calculator, should be approximately equal to 4.5. Okay, and then we're just going to repeat the process. So I'm going to go ahead and start this over, and we'll do it for the other 3 segments. Okay, this time we're going to find the length for segment AD. So I basically copied the problem down. I moved my x2, y2 over to point D. I'm going to fill in the blanks here, and we're going to find an answer. Okay, so AD, my x2 this time is negative 2 minus 0, and y2 is 0. When I subtract a negative, make sure this turns into plus. Oops, never mind, that wasn't a negative. Positive 4. My bad. Okay, this gives me negative 2 squared. This gives me negative 4 squared, which is 4 plus 16, which is also the square root of 20, which is equivalent to 4.5. Okay, 2 more times. This time I want to find the length of BC. And you'll notice I put in my x1s and my x1, y1, x2, y2, and now I'm going to fill in the appropriate spot. So 2 goes here, 4 goes here, negative 2 goes here, and 2 goes here. In the first part we get negative 2 squared, negative 4 squared, which gives me 4 plus 16. And like we guessed, which is also equivalent to 4.5, and 1 to go. And the last length we need to find is CD. So I put in the appropriate x1, y1, x2, y2. Negative 2 goes in this spot. Minus 2 here. 0. Try that again. 0. Minus a negative here. Here's where I get my plus 2. This gives me negative 4 squared plus 2 squared, which is 16 plus 4. oops. Which we know is the square root of 20, which is equivalent to 4.5. Okay, last screen. Therefore, segment AD is congruent with segment AB, which is congruent with segment BC, which is congruent with segment CD. And our conclusion, our finale, therefore, quadrilateral ABCD is a square. A lot of work for that, huh? Because it has 4 right angles and 4 congruent sides. And 4 congruent sides. And that's it for notes.